Hi there, welcome to Machine Bytes, your go-to place to learn AI the smart way. In this video, we will do one end-to-end ML project touching all the topics that are coming on the way. This video will be divided into two parts. In first part of video, we will just discuss the theoretical steps that are involved in end-to-end machine learning model. And in second video, we will complete the project practically. Understand the end-to-end process. We will be picking the housing dataset from Kaggle, which aims at predicting the price of house. In this dataset, we have some features, and on the basis of these given features, we need to predict the price of house. Let's explore all the steps that are involved in end-to-end machine learning problem. The first step is understand the problem. Understand or frame the problem. The first question you ask your supervisor is what exactly the business objective is. Building a model is probably not the end goal. How does the company expect to use and benefit from the model? Knowing the objective is important because it will determine how you frame the problem, which algorithm you will select, which performance measures you will use to evaluate your model, and how much efforts you will spend tweaking it. Now, since you have the answer to this question, that is, we need to predict the price of house. That is our end goal. The next question we need to ask is how the current solution looks like, if there exists any. Let's say the answer to this question is as of now, it is being done manually by experts. So definitely this will incur a lot of cost, and having a machine learning algorithm will reduce the cost. Now, since we have these answers, we need to ask ourselves which kind of algorithm we are going to go with, whether it will be supervised or unsupervised algorithm. Now, after we have these answers, we need to decide upon what kind of algorithm we are going to go with. For example, supervised, unsupervised, or reinforcement. Then other question that we need to answer is whether it's a classification or regression task. Once we have answer to this, we also need to decide whether we are going for batch learning or online learning. Once we have answers to all these questions, we can go to the next step. The first step is very critical because here we are setting up the expectations that are there from this particular algorithm. And on the basis of those expectations, we are devising our solution. Once the problem is clear to us, the next step is collect the data. In our case, we already have this data set over Kaggle, but for other scenarios, maybe you may need to get the data from some API or do web scraping, or maybe get the data from related industries. Now, once we have the data, first we want to split our data into two subsets, that is train and test split. This step is crucial and must be done before doing any data pre-processing. Why? Because if you are doing the pre-processing on entire set of data, then your model will be able to see the part of testing data also. The logic is at first we should divide the data into two parts. Say if this is the entire data, it should be divided into two parts. One is training data, other is testing data. So any kind of training should be done here. This data should be provided to model and then testing done be on this model. So now keeping these two data segregated we are sure that our model has not seen this data before evaluation being done on here. But if we have the entire data and we are doing pre-processing on the combined data, then the data leakage will happen. The next step is EDA, exploratory data analysis. Under this step, we will visualize the data using graphs. This will help us to find out any patterns in the data. We will also assess for any correlation between different features. Other thing we do is detection of outliers. EDA will also help us to find out if the data set is imbalanced. This step is done to understand the data better. Next step in the process is data pre-processing. Now, since EDA is already performed in the last step, we know all these things and are aware of the entire data. So in data pre-processing step, we will perform the tasks to clean the data and make it more appropriate for model training. So the tasks that are performed here are like remove duplicates, then we need to handle the missing values. To handle the missing values, one we can do is just remove those records, but this should be done only if we have enough data points, and removing these data points will not impact our training. The other thing we can do is fill the values for the missing data points. This can be done using mean, median, mode, and there are other methods also. Other thing we do is remove the outliers if they are not true values. What does this mean is sometimes outliers might be the actual values that are observed in the field. So in that case, we should not remove those outliers. The other thing done is scaling of data. Scaling of data is done to scale all the features to same scale. For example, if we have marks of primary school students along with their age. Now the age column values will be from around 5 to 10 years only. But when we say marks, marks can range from 0 to 100. So these both are on a different scale. But if we divide marks of all the students by 10, then these both features will be on the same scale and the values will be between 1 to 10 only. Other crucial step that is done under data pre-processing is handling of textual data. If we have some feature where the color is the value, now the values will be like red, blue, green, like that. But our machine learning algorithms can't understand these values. In such cases, we do convert these categorical columns into some numeric value. There are different methods using which this can be done. We have ordinal encoder, we have label encoder, then we have one hot encoder. We will explore all these topics in detail in upcoming videos. Once the data is pre-processed and cleaned, we move to our next step, which is feature engineering and selection. As the name suggests, there are two tasks here, feature engineering and then feature selection. So for feature engineering, we might need to update existing features, create new features from existing ones, or drop the features which are not required. And then from all the features that are available to us, we need to find out which features are helpful and select those features. Having not helpful features in training data will only lead to malfunctioning of the model. Once our data is pre-processed and we have selected our features, now we need to understand what performance metrics we are going to follow. Since this is a regression problem, so we can follow mean square error, root mean square error, mean absolute error, all these performance measures. The next step is to train the model, evaluate it, and then selection of the best model. To train the model, we will pick the different regression models like linear regression, support vector regression, decision tree, and there are many others also. So on the basis of nature of data and the mathematics behind these algorithms, we can shortlist some of the algorithms that we want to train on our training data. Then we will evaluate these all models using these evaluation metrics. And out of these all models, then one will be the selected, which is having the best results. Now, when we have the data cleaned, our features are selected, we have decided upon one algorithm and has acquired a satisfactory level of accuracy, we can move further with model deployment. One of the method of deploying model is converting our model into the pickle file and use that over the API that is created for that particular model. We will have one Python app on which user will input their new data points, and then this Python app will give a call to API. API will call this pickled model, and so whatever result is found from here in JSON format, that will be passed again to the Python application and will be displayed to customer. Now, once our model is already live, still there are steps that involve in end-to-end cycle of machine learning models, that is retraining and testing. This particular model was deployed into the production during the month of January 2025. Now, in June 2025, between this time period, there will be more data points. There will be new properties added to the dataset. And there might be a change in the market also. There can be inflation, or because of some event like COVID or some war, there might be reduction in the prices also. But since our model was trained on the data till 2025, it will not be able to predict the prices considering all these points. So to tackle that, we need to retrain our model on latest data. So once retraining is done on latest data, now we want to know if the version 1 of model was performing well or the version 2 is the better one. So to do that, we can perform A/B testing. So using A/B testing, the incoming traffic of customers is divided onto two versions of the model, V1 and V2. And we see which version is performing well. On the basis of that, if V2 is performing well, we will retain that and deploy into the production. But if V1 is performing well, then we need to roll back the changes and stay with version 1 only. That's the end-to-end cycle of machine learning problem. That's all for this video. In next video, we will see the practical implementation of all these steps. Thanks for staying till here. Bye bye. Take care.